Welcome to Arduino Made Easy. This is lesson 3. Today we're going to talk about analog read, analog write. We're going to go a little bit deeper into serial communication, and we're going to talk about pulse width modulation. So let's get started with this right now. Hi, I'm Tom Kvichak, and this is Tom's Trains and Things. This channel was created to help other modelers who are in need of guidance in pursuing their dream of building a model railroad. And in that railroad, if you want to have some automation and lighting, Arduino is the way to go. It is so simple, you would be surprised how easy it is to get your buildings lit up and to do a little bit of automation on your model railroad. And we're going to make it a little bit easier for you. Arduino is already pretty easy to figure out, but those of you who have not had any experience in electronics and coding, it might be a little bit difficult for you to do. So that's why I'm here trying to teach you a little bit about the electronics part and the coding part as easy as it can be. So after this, we're going to get started with this. If you would like to see more videos like this on model railroading or on Arduino automating your model railroad or anything else concerning model railroading, go ahead and hit that subscribe button, and while you're at it, ding that bell, and that'll notify you whenever I have a new video coming out. And speaking about videos, go ahead and check out my playlist. You can check them out down below in the playlist page. I have over 40 playlists there, categorized by subject, so they are easy to find. So go check them out. So let's get started with this lesson 3 right now on analog read, analog write, serial communication, and a little introduction to pulse width modulation, which you are going to hear a lot about. Let's start off by identifying the analog pins on the Uno. Now on the Uno there are 6 analog pins. If you have a Nano or Mini, you have 8 of them. If you have a Mega, you have 16 of them. So we're just going to concentrate on the Uno right now from A0 to A5. Now this is a SMD chip. It's the Atmel Mega 328P. Now this is the SMD version. There is a conventional version that I have on this one right here, and you can see it right there. Now it has an analog to digital converter. So whatever sensor, analog sensor that you put on these pins right here, it's going to change that analog signal to a digital signal. And we'll talk about that right now. Any sensors that we hook up to the analog input, whether it be a potentiometer, a ambient light sensor, a temperature sensor, anything that will give you a 0 to 5 volt reading on those pins, the analog to digital converter converts that into an integer between 0 and 1023. Now that means every unit is about 4.9 millivolts. So that's a lot to take into consideration. Now, where do we write these? Well, we write these on the pulse width modulation pins, and you'll notice those pins have a little tilde on it or a little dot next to them, and I'll show you on here. Now you'll notice on the digital side you'll have pins 3, 5, 6, 9, 10, and 11. They have little tildes right next to them, and on some of them they just have a dot. These are the PWM pins on here. Now what that means is pulse width modulation, and that takes the analog signal that we get from here and it reads it on here as digital signals. Now let me explain that a little bit further for you, because this is where it gets really interesting. How do we take a signal that flows to nothing more than an on and off signal. So that's what we're going to talk about with pulse width modulation. Pulse width modulation is a technique for taking an analog signal and converting it into a digital signal. So how is that possible? Well, the digital signal is nothing more than 0 volts and 5 volts. And in our pins, we read that as 0 for off and 255 for on, or 0 for low and 255 for high. But wait, they create a square wave. Okay, the pulse width modulation technique creates a square wave in a duty cycle. So whenever you have a signal that is off, you have 0% of that wave in the duty cycle. Whenever you have 5 volts, the full 255 on that signal, you have 100% of that duty cycle at 5 volts. So you see where I'm getting here? That's how we change the analog signal to a digital signal and read it on our PWM pins. Now it's a little bit confusing at first, but I'm going to put a graphic over here and show you the different duty cycles on there, and you might be able to grasp it if you look at it and then you review my explanation of it, where the 25% you have a number 64 coming from your potentiometer. That's 25% of the duty cycle. So 25% of that duty cycle is going to be at 5 volts, and the rest of it is going to drop down to 0 for the rest of that cycle, and it's going to continue that way until we move that potentiometer to a different position. And the more that we turn the potentiometer up higher, the longer that the longer that area is where we have the 5 volts on, and the shorter where we have the 0 volts. So it's just a matter of how long in that duty cycle we have the complete 5 volts on. That's how that works. I don't know if I made it more confusing for you or if I cleared it up any, but just look at that graphic over there, and that'll explain it. It's nothing but ups and downs, and how long the up is compared to how long the down is in a given time period. That's what pulse width modulation is, PWM. I hope you got it there. Last week when we did the serial monitors, we had nothing but ones and zeros because we used the button. It was either on or it was either off. But with the potentiometer, we could read 0 to 1023, or we could read 0 to 255, or we could read 0 to 5. Do we want to figure out how much voltage we have, or do we want to figure out what the actual reading is between 0 and 255, or do we want to know what it is between 0 and 5? Now, it may sound a little strange right now, but later on when we start looking into sensors and looking into readings and whether we want to turn the thing on or turn the thing off, it'll all come together then. But we're just going to go over it now. I'm going to show it to you on the screen here. We're going to start off by identifying the potentiometer, what value we're going to give it to begin with, and the two LEDs on here. So let's start off with the potentiometer. And we're assigning it to AO. INTVAL equals 0. Now my LEDs, number 1, and we're going to put on pin 3 and pin 5 since those are the PWM pins. All right, now that we got that, we'll go down into the setup. We'll move this out of the way here. And pin mode. My LED as an output. Oops. 2 also is an output. And we'll start the serial monitor. All right, now that we got that going, let's go down into the loop. And all we want to do from the very beginning is we want to print the value that's on the potentiometer. So you could see up here we have value. We start the value off as 0. Now in the loop, we're going to identify it as an analog read. From the potentiometer pin. And so the only thing we want to do right now before we turn on any LEDs or anything like that is we want to print out and see what the value is when we turn the potentiometer. So what we do there is we do a serial AL print line, and then we'll go VAL. Now we want to be able to read what's on the serial monitor, so we'll put a delay in there of ½ a second. And then we'll go back and correct the mistakes I made. I took the parentheses out and forgot to put the 0 back in there. And when I was thinking about my LED 2, I put print mode 2. So I think that will work right there. But since I don't have the Uno hooked up right now, it's not going to be able to compile because it needs to have something hooked up to it before it will compile. We'll save this and we'll format this. Auto format, and it'll move the things out and make it look a little bit prettier. And what we'll do later on when we're finished, like always, we'll put the comments in there. If you remember in our last video, we had the 2 buttons in here and I just moved them off to the side. Here's a potentiometer that you could use. You've seen this in some of my other videos, but I'm going to use a potentiometer like this. It's a little bit bigger and it's the same thing. It's a 10K potentiometer. Now in the last video I had these 2 jumpers going from my buttons over to the ground rail and the power rail. And what we're going to do is have these 2 end pins, one go to ground and one go to the 5 volts. So I'm going to turn it around this way here so I could put another wire in there, and we'll have it right there. And since we're going to be going to AO, we'll just put this on AO right there and bring this over to the center pin on there. Now we're going to put this on the ground, and we have a ground pin right here. Make sure I get the right hole in there. And on our positive, our 5 volts, we'll stick it over here. and run it over onto this one right here and make sure we get it in the right one. All right, now we're going to be using number 3 and number 5. I got to turn this around to see it. So 3 right there, and 5 right, oops, skip 1 and 5. Okay. 1, 2, 3, 4, 5. Okay, so now we got 3 and 5. We got AO over here to the center pin on the potentiometer. We got our 5 volts going to one side of the potentiometer, and here is the ground wire right here, the black wire. So we're good to go on this. Just disregard everything on that side right there. Now that we have this all hooked up, let's compile our sketch. And so far so good. All right, there we go. Now we'll upload it to, and before we do that, we'll make sure that it recognizes it's genuine Arduino to COM port 5. Okay, we'll upload it. Okay, and it's going to stop the LED from fading in and out because we don't have anything on there except for the print value. So we'll open up the serial monitor here, and you'll see it's printing out 362. And as we increase this on the potentiometer, you can see it gets higher and higher to when it's all the way up to 1023. Now let's go down to the other end, and we'll do this a little bit faster, and you can see it's at 0. Okay, so let's try to get this up around halfway. So that should be around 512. Okay, so you can see how hard it is to get a precise number on here when you're trying to dial it in. So that's why we're using a potentiometer to start out, and we'll use whatever value we need to put it in our code. Now, we're seeing 0 to 1023 on here, but let me show you something else. Now, we're going to change a few things on here. First way I'm going to show you here is we're going to take the value and divide it by 4, and that will give us 0 to 255. Now, let's pull up the serial monitor once this thing uploads. Now you see it's at 128. That is halfway. That's right in the middle. So we'll come up to the highest point, which is 255. And we'll go down to 0. And there we go. So you saw 2 different ways on here that we could read it. We could read the actual values of what's coming from our pin on the analog side, or we could read the digital value 0 to 255. I'm going to show you another method to change the values that we're reading on here, and it's called map. So we're going to take the value and we're going to map it to, and we'll call it value again. And what we're going to do is we're going to take the original figures 0 to 1023, and then we're going to put in 0 to 255. and that's telling the map function that we want to take value and we want to call it value from 0 to 1023, and we want to map it to 0 to 255. That's what we want to read on serial print line value. And we'll compile this. And upload it. And without showing you it, we'll just show you the serial monitor on here, and I'm adjusting the potentiometer. I'm bringing it down to 0, and then I'm turning it the other way, so we'll go all the way up to 255 on there. So you saw on there where we could take the value and divide it by 4 to get to 255, and then we use the map function on here to change the value or remap the value from 0 to 1023 to 0 to 255. I just wanted to show you that right there, so because we're going to be using that in the future. Now the next thing we're going to do is light up the LEDs, and the way we're going to do that is put in the analog right. So we'll start over here, and I commented out the delay for the analog right. And what you see is my LED 1, and then we're going to use value, and value is whatever we read on the potentiometer. LED 2, EAL, boom, boom. Okay, now that should be okay. And the reason I took the delay out is if I would have left that delay in there, you would see like brightness of the LED going down in steps, and I'll put it back in after I show you the first part of this. And we'll take a while to upload it. It compiled it. Now it's uploading. There we go. All right, there we go. Now we'll take this and we'll bring it down, and then we'll bring it back up. Now on camera it kind of distorts the LED, the brightness on it, so it's not going to look exactly like that. It looks better in real life. So I'm going to leave it right there. Now I'm going to put the delay back in there, and you can see what happens with it. Now with the delay, it's going to stop a half a second to read. Now whenever everything that's in that loop with that delay in there, it's going to delay everything in that loop. So it's also going to delay the value that goes to the LEDs. Okay, now as I decrease it, you're going to see it step down instead of go smooth. Okay, and you can see that right there. Now let's bring up the serial monitor. And the reason why we want to do the serial monitor is because if we have a sensor, and it doesn't have to be a potentiometer, it could be anything that we're working with, we want to know what value it works best with the sketch that we're writing. So we want to replace whatever this potentiometer is, replace that with our sensor and play around with it to get the right setting in there, so we could turn on or turn off something, or get the right brightness, or whatever we're using in there. We will use this and the serial monitor to figure out what settings we want, and we could either hard code that in there, or we could set limits on it through the the map function over here. Now let me do something with the map function. I'm gonna keep the values in there, but I'm going to change it between 100 and 255, and you'll see what happens there. When I turn this all the way down, it's not going to go completely off, so it's only going to go between 100 and 255. You can't really see it on there, so let me go on the other range of it. I'll go from 0 to about 125, and we'll do it that way, and we'll see what it looks like now. And okay, it starts out at 0, and then it only goes up to 125 at full throttle right there. Let me take the delay back out of it so you can see what it does smoothly instead of in steps. Okay, there we go. Now bring it back down. Okay, we're going to see what that reading is right there, so we'll bring up the serial monitor, and that's set at 50. So what we're going to do is we're going to set the low point at 50, and so that it won't go any dimmer than that right there. And so we'll upload that, and I'm turning it down, and it doesn't go down any further than that, but it will go up to our set point of 125. Now I have this all the way up right now, and we have that part set at 125, so we'll change that up to our maximum 255, and we'll see what that does. Okay, now it's bright all the way, and we'll bring it down, and it's only going to go down as far as 50. It's not going to go to total dim or total blackout. So that's the good part about the map function on there. You could set your limits in there. You could also do that in another function, constraint, but we won't go into that one this time. We'll go into that a little bit later on, but this is just to give you an idea of how you could play around with these numbers and the reason why you want to play around with these numbers. Say you have a ambient light sensor, and we'll get into that later on, but that's what most modelers use whenever they want to operate their crossing gates and lights. They put them between the ties, and as the train goes over it, it changes value. So what you have to do is, once you have the ambient light sensor in place, you have to use the serial monitor to find out where that sweet spot is, where it will trigger your crossing lights and gate. So that's the reason why you want to have this serial monitor. You want to be able to monitor what your values are, so you could write that into your code to operate your devices. Okay, so I hope this helped out. This is as far as we're going to go. I ran pretty long on this one again, but you have a lot of information in there. Go back and try different things with your sketch. It's a good idea to go in there and change some of the numbers and to experiment with it. You know, don't just do what I do here. You know, do some other things and get familiar with coding and changing things around and see what happens in there. You know, just by changing this, if we go in there and change, let me pull that part up in there, let me see. If we go up there and change this value right here other than 0, we're going to have different results. So go ahead and try doing that. I mean, you could go up to anywhere up to 255. I wouldn't go higher than that. But anyway, you know, try 50, try 100 and see what happens. Your LED, whenever you run it back and forth, whenever you run it back and forth the potentiometer, you're going to see your LED go bright and then dim and then go bright and then dim when you change that value on that first value over there, because that is a global value because it's above the setup. Everything in there is based on that value right there of 0. Now, whenever you change your value in the loop, that changes it in what you're doing on your project right here, and it uses that value up on top as a starting point. Go ahead and pause your video and take a look at the code and the fritzing diagram. And for your information, I usually put these up a couple of days ahead of time of the video, so if you would like to see them ahead of time for future episodes, go ahead, maybe on Thursday or Friday you could see them up on my website, tomstrainsandthings.com/Arduino. I hope you learned something. Go ahead and experiment with it. Next time we're going to be doing if statements, for statements, and while statements, and you'll see we'll be able to operate these LEDs and without having to code a lot of different things in there. We'll be able to use if, for, and while statements to step things through and count, and we'll get into that on the next lesson, lesson 4, and that's coming up next week, so take a look for that, and we'll see you.